in this championship. I'm very happy to be here today. The name of my talk is a deep dive into TAGE-SC-L. As Andre said, and did a very nice background of what it is, what it was from 16, sorry. So I will skip all these details that he already presented. So that's good. What was my motivation before this contest? To understand that code in TAGE-SC-L. I knew what was how it works, longer history, alternative prediction, all these things. I was teaching in the master of that, but very far with what I was teaching through all the details that are in the code there. So I wanted to know why it was so good. I focus only on improving MPKI because after that you will improve also GROMPA. Yeah, and was indeed a very deep dive in learning how TAGE work, not in results maybe, was very, very, very hard to improve it. Was thinking I was like trying to dive into the sea, close to impossible, right? But well, as Rami said, 1% is good, so here we are. I hope at least some of the ideas that we will present are nice and can be applied to the TAGE that are presented, to present predictors and others that will be presented here. So I will start with the 192 TAGE-SC-L that I did as a baseline. Then 3 acts. History is not how it was told, how to be more confident, and be careful with feeding the beast. And then other fine-tuning that I did. So yeah, TAGE is the state of the art, and I keep a new baseline, very similar probably to Andre Ramirez. 8 times more for the bimodal table, that was giving big improvements. For the TAGE table, 2 times more, also more banks. It's not realistic, but it's what it has to be done to get maximum minimum MPKI. And then loop predictor, I keep the loop predictor. I work a lot on it, give small improvements only, but well, I like it as a concept, and I think, as I say in the paper, it can be easily propagated, the information from prediction to the later stage in the pipeline. 2 times also for the statistical corrector, it's table there. Thanks for path history and other parameters that are there in TAGE. Quicker, a little bit. And I mentioned 28 histories. I have this 42 numbers, so it's 21 histories. And this is 344. Okay, this is what was TAGE. So very, very hard to improve from that. Very fine-tuned TAGE to the latest is super hard to get more. First, history is not how it was told. Andre mentioned we should concentrate on the middle history. So he noticed before we have here geometric histories. Here is a logarithmic scale, that's why you see as a straight line. These are the 21 histories, and Andre in the code in 2020 and 2016 did some tricks to remove some histories. I don't know if the pointer is here.
Middle.
Middle, okay.
Yeah.
To remove histories here and here, sorry. Yeah. To assign one weight to some of the histories and to weight some to other ones. This point here maybe because I also move 2 more histories, so probably these were not in Andre's code. So, as Andre mentioned, this should increase slower, have more histories of that, and this here should increase faster. So what we did? So what increased at the beginning faster and then gets slower? A quadratic sequence. So we have here the square party of number blocks, and it's increased this way, right? Start faster than geometric, and at some point it's flatter. Okay. What we want is here go slower, but at some point go high again. How can we do that? Sorry. Yeah, well, after this, we start going to the generalized geometric sequence when we have multipliers and go increasing these multipliers. So it's what I call this square, starting square, and then super exponential. This can summarize with this formula here. Start with the first history, adding differences. If it's squares, increase by 2s, this is equal to here, and then geometrically with f is the factor that you increase each multiplication that you do. And you have threshold to change from one to another. So quadratic sequences grow by a factor of 2. You have a square here, right? The next one is 4, so plus 3, plus 5, so on, right? So they increase with b equal 2. And then we have the generalized geometric sequences. So being this the formula, we start with 2. The smaller history is 2. Increases, so the next square would be 5, 10, 17, so on. And then after 15 histories, we are changing to multiplying by 1.1, then plus 0.1, right? 1.2, 1.3, 1.4, and so on. We increase faster and faster. We also try with the equal 1, third party, but was not as good as the square party. Still better than the geometric, I would say. So this is the final history set. This increases in the way that I mentioned. One nice part is that it's not as QCAS anymore, or at least it's only one way what we try. So it's a little bit simpler. Part of the things that I try to do is to improve performance, also try to simplify code and concept. Sometimes that's not possible, but sometimes. 3, 4, 2, 76 with this one. Next one, how to be more confident. Well, TAGE has 3 main choosers. And then if we select between the choosers are many components, right? So we need to select from the alternative predictor to the hit predictor, from the loop versus TAGE, and SC versus TAGE-L. So a few improvements here. TAGE-SC-L discard loop prediction if the statistical corrector is very confident. So they are merged, the loop predictor with the TAGE, and they are together having the confidence of TAGE. What I say is that the confidence of the loop should be taken into account, because the loop predictor is the most confident structure in the TAGE-SC-L predictor. So we increase, in that case, SC never overrides loop. Also, loop predictor is not fine grain from 0 to 7, 0 low confidence, 7 high confidence. So and then here, threshold is the loop iterations times the repetition that this loop iteration appears. So 128 is the threshold to claim is confident or not. This 128 will be 7 significant bits in the binary content, in the binary format. If it's 6 bits, then less confident, 5 bits, and so on. So I use these bits here for the confidence from 0 to 7 to also choose if the loop predictor will take it over SC-TAGE or not. I also put the confidence of TAGE and the confidence of SC to be able to do a good choice. This is 5 bits, so we need 2 to the power of 5, 32 entries, choosers, okay? And they are the same choosers that the user moving high when this put the predictor on one side and low when this the other one, and we choose depending on that. Alternative prediction. This the key difference here is that we choose the alternative prediction when the confidence on the hit bank is 0 or 1, from 0, 1 to 3. In that case, we check the alternative bank and we evaluate its confidence with the hit confidence. And here, basically, this is the extension that we do here. I use 2 bits here for the hit confidence. It's only 1 because this only can be 0 or 1. This was a little bit of mistake. I use more budget than the one that it really uses. So this will be 250 56 counter, while only 128 are really in the code. And finally, the statistical corrector prediction, very similar to Andre, but Andre used two counters only for efficiency. But I just let all the predictors to fight. Okay, all the confidence of TAGE, which is 3 if it's maximum, 2 if it's medium, and if it's low, we choose if it's the alternative or the heat bank. And this is exactly 3 bits. It's 2 bits, only 3 values, so even less context. That's what they claim in the paper that I need. Liter, that's 3, 4, 2. And finally, be careful when feeding the beast. TAGE is able to predict everything, not everything, but many things, very fast. It's in loops, but we need to be careful not to predict, not to add information to it when the other components can do it well. For example, for a very easy loop predictor, I was seeing that TAGE was allocating more than 100 entries. That couldn't be a good sign, right? So the key thing here is not to allocate in the TAGE prediction if the loop predictor is telling you it's very confident. And with that, it's much simpler logic. I tried to remove many of the random pieces that are there in the code, and I did many, not all. I wanted to do all, but I couldn't. With some heart in MPKI. But from here, it's very simple logic, singly, and it worked quite well. And the replacement policy, I didn't have time to work more on that, but I think it's key. It's key. Some research has to be done there to replace cleverly the entries in TAGE. Okay, I just increase the useful bit of the alt bank when it hits over a miss that give a little bit more performance, not much, but it's where we are. 3, 4, 1. And then finally, other fine tuning. So in the loop editor, how to change the loop faster when the direction that you insert is the wrong one. Some resetting of the tags. I removed the small IMLI table. Maybe I should have been the one that Andre just presented. That would have been better for sure. And some small things in the hashes and increase the second and third history from like tables. And that comes with the final number 3, 4, 1. So what did I present, or what was the thing? So we have a number of simple optimization for TAGE-SC that hopefully do not that much more complexity of what it has. New history lens series that the quality is super exponential that I think can be integrated in any other predictor, not only for TAGE. And to give it a name from quadratic, sequence quadratic, I have TAGE-SC-L. Just to be a little bit different. So, thank you.